Good evening, everyone. Uh, my plan here tonight is to answer as many of your questions as I can. And in any downtime that happens, I have a pile of questions from previous finals that I have drummed up to go over. So if you don't have questions, I still have plenty of things to keep us entertained for tonight. Uh, Feel free, of course, tonight to ask about anything from Sample Final A, but also feel free to ask anything about the test or the homework or any of the other things that come up. And we have a little chat box here so you can ask whatever you like, and I will get to it in as orderly a fashion as I can. A lot of people have emailed and asked when the next finals a lot of people have emailed me to ask when the next finals will be available. I have posted the second sample final, which is sample final C. You can find that on Katie now. That'll be due tomorrow night. But in general, I'm not going to be able to post the sample finals more than one at a time. Because of the fact that for some people, the final that you're getting as the sample final was already was their final, so I basically just have to give them out one at a time, so that I'm not giving everyone the same final at a bunch of times. All right. So let me start with this question, and then I'll open it up and ask whatever people want to ask about. So let's do one of these ever popular derivative questions. So this is a product rule question. So we're going to let a here be x squared, b be the natural log of x. So a prime is 2x, b prime is 1 over x. So if I go ahead and take the derivative here, that will give me a prime b plus ab prime and so if I simplify this, okay, something like this. And because the question actually asked for the second derivative, it would be in my interest to simplify this even further. So I'm going to write this in this fashion. All right. So, having gone ahead and done that, I can now grab the product rule to take the derivative of this again. So the first piece of the product is now just x. The second piece is 2 log x plus 1. So a prime here is 1. Oh, why did I write b prime? This is b, not b prime. B prime here is 2 over x. Sorry about that. And so if I now work this out, you get that f double prime of x here is 1 times 2 log x plus 1 plus x times 2 over x. Which is to say that f double prime of x is twice the natural log of x plus 1 plus, and then this will be 2. So f double prime of x in this case is twice the natural log of x plus 3. And so in light of that, when we go to find f double prime of the square root of e, will work out to be 2 times, and the natural log of square root of e, remember, is a half, plus 3. And so this will be equal to 4. Okay, so before I open up the world to whatever question you want, I'll ask if there are any questions about this question that I just did, or if there are any questions about any of the administrative stuff for the course. So if you have any questions about the final or anything of that sort, now would be a good time to ask. And then I will open it up and answer questions from the sample finals or whatever. There will be 4 sample finals, 1 per day until Friday when you'll take the actual final. Do remember that if you want to take the final early, you can make arrangements with me and I will let you do that. So when you feel like you're ready for the final, or if just it works better with your travel schedule or whatever, you can let me know. But if you don't do anything, there'll be a sample final Monday, Tuesday, Wednesday, Thursday. And then on Friday, you'll take the actual final. I've said this before, but I'll reiterate. I do not know which of the sample finals is the actual final. I've been letting people who take the final early pick which final they want to take. So it will be one of them, but that means that your sample finals that you have should be very accurate as to what the final is actually like. Okay. And yes, it's a good time to transition into this, so I will happily talk about question 4 from the sample final. Okay, so this is A4. And so we've got a point here and a point here. We've got the secant line through those. And then a tangent line here. And so we're asked, hey, what's this point? And the information we're given is these 2 points are, I've already forgotten, are e comma something and something comma 2. Okay, this is all on a graph of natural log of x. So these 2 points, let's start with those. These are both points on the graph, and so these are input-output pairs. In the case of this one, e is the input. So this should be the output, which should be the natural log of e, which is 1. Up here, we want the input that corresponds to an output of 2. So in other words, we want to find, okay, what number could I put into natural log of x that would give me out 2? And so that number has to be e squared. Okay. So that will fill in these 2 points. Now, a key observation in the picture you're given is that these 2 lines are parallel, so they both have the same slope. And now that I know I know 2 points on this lower dashed line, I can actually calculate the slope of the lower dashed line But because the lines are parallel, it's actually the slope of both of them. So that slope is 2 minus 1 divided by e squared minus e. So it is 1 over e squared minus e. I'll pause for a moment. If there are any questions about anything I've said so far, I will be happy to answer them, but I will continue after a moment if no one asks anything. Okay, well, I've got to finish going over this one first, but then I will do number 2 next. Okay, so this is a tangent line with slope 1 over e squared minus e. That's the summary of what we know. Okay, so we're trying to find the point where the tangent line has slope 1 over e squared minus e. So if I take the derivative of the function, get 1 over x. Remember, this tells me the slope of the tangent line at each place. So I'm looking for the point where 1 over x is 1 over e squared minus e. Okay. Namely, I'm looking for the place where the slope of the tangent line is that. Fortunately, if I just cross multiply, it gives me right away that the answer is that I'm looking for e squared minus e. Okay. So this third point up here that I guess in the picture is labeled question mark, the x coordinate of that point is e squared minus e. And so, since this is a point on the graph of natural log of x, it's an input-output pair. So that's the input. So the output is natural log of e squared minus e. Okay. Note, you may wish to simplify this in some way, but this does not really simplify because you can't distribute the natural log here. So be careful, that's as good as this is going to get. Okay. Any other questions about 4? I'll do 2 next. Why do I compare the slope to the derivative? The reason is because the thing I know is that, so taking into account, I know this line has slope 1 over e squared minus e. The thing I know is the tangent line at this mystery point I'm trying to find has slope 1 over e squared minus e. And that's because it's parallel to this other line that had slope 1 over e squared minus e. And so the reason, to then answer your question, why we end up comparing the derivative with the slope is because I'm really looking for something that is the tangent line, or is the slope of the tangent line. And so it's the derivative that tells me the slope of the tangent line, not the original function. Feel free to ask further if that did not clarify things for you, or if anyone else has a question, or if not, we'll move on to A2. No problem. Happy to help. Okay, let's look at A2. Okay, A2. Okay. And just to clarify, we mean A2 and not A1.2, right? Okay, so this is a quotient rule question. So A here has to be my numerator, B here has to be my denominator. A prime will be 3, B prime will be 2. So when I go ahead and write down the quotient rule here, it will tell me h prime of x is a prime b minus ab prime over b squared. And I want to emphasize, because this is something I've been catching as I've been grading test 6, a lot of people have been writing the quotient rule backwards. The quotient rule has to have the numerator in this order. If you flip it, then you actually change the sign, which ended up getting a few people in trouble on their first derivative tests. So be careful that you use the right version of the quotient rule. Okay, and so in this instance, that's going to work out to be a prime will be 3 times b, 2x minus 7, minus a will be 3x times b prime, which will be 2, all divided by 2x minus 7 squared. 6x minus 21 minus 6x, all divided by 2x minus 7 squared. So this will be minus 21 over 2x minus 7 squared. Okay, and that will be my first derivative. Okay. I need to take the derivative of this again, so I'm going to need to use the quotient rule again. Okay. When I go to do that, my numerator here is now minus 21. My denominator is 2x minus 7 squared, which is the same thing, now is a good time to note, as 4x squared minus 28x plus 49. Okay. So my a prime here is 0. My b prime here is 8x minus 28. Note the derivative of minus 21 is 0, so when you actually take the derivative of the numerator, you will actually get 0. Okay, so then that means that h double prime of x will be a prime, which is 0, times b, which is 2x minus 7 squared, minus, and then a, which is minus 21, times b prime, which is 8x minus 28. And this will all be divided by b squared, which is 2x minus 7 squared squared. Now, important to notice that because this is 0 times 2x minus 7 squared, this whole term just disappears. Because 0 times anything is 0. It doesn't matter how complicated or messy the anything is. So let me try and clean this up a little bit. So I have a minus, so that's a plus. And I can factor a 4 out of this thing. So that will be 21 times 4 times, and then what's left will be 2x minus 7 divided by 2x minus 7 to the 4th. But actually, if you look closely now, there's a 2x minus 7 in the numerator and 4 of them in the denominator, so I can cancel one of them. And be left with 21 times 4 over just that denominator cubed instead. And so this will be 84 over 2x minus 7 cubed. So that is our second derivative, all simplified. But the question actually asked for h double prime of 4, okay, for which I'm going to have to plug 4 into here, which is going to be that, which will just work out to be 84. Any questions about that? Or if there are no questions about that, any questions about other questions on the final? I can go over 10. Let me just wait just a second and see if anyone asks anything else about this one I just did. And if not, I will go over 10. Okay, so 10 asks about using the limit definition to find the derivative of f of x is the square root of 2x squared plus 7. So remember, to do this, we need to find our 2 points. So we'll start at this point on the graph. And then we'll bump that point a smidge to the right. And then we'll find the average rate of change between those 2 points. And we need to simplify this. And so this is one of those square rooty kind of limits. And so we need to use our multiply by the conjugate trick here. So I will do that. Okay, so now our numerator becomes 2 times x plus h squared plus 7 minus, and then 2x squared minus 7. And our denominator is this kind of messy thing. The plus 7 and minus 7 are going to cancel. And I'm going to have to FOIL out this 2x plus h squared piece. Which when I do is going to give me this. Okay, so now the plus 2x squared and the minus 2x squared cancel. And now I'm left with a numerator that I can factor an h out of, which remember is my ultimate goal in all of these limit definition of the derivative questions. And so finally we can cancel our h's. And remember that once we cancel that h from the denominator, that's when we can finally go about calculating the derivative itself. And the derivative itself, remember, is going to be the limit as h goes to 0 of that thing we just wrote down. Okay, so when I look at the limit as h goes to 0 of the numerator, all that's left is a 4x. And in the denominator, I'm going to have a square root of 2x squared plus 7 plus another square root of 2x squared plus 7. And so that is going to be 4x divided by 2 times the square root of 2x squared plus 7. Okay, and I can shave a 2 out of both the numerator and denominator, so this will be 2x divided by the square root of 2x squared plus 7. And that will be our answer. I'll make one note, which is that there are a bunch of kinds of these limit definition of derivative questions that we've done over the course of the semester. And now some of them we could now do with our derivative rules, and some we can't. Okay. So this is one, we could not do this derivative any other way. We can only do this with this definition. But sometimes it will happen that you'll be asked to use the limit definition of the derivative to calculate the derivative of a fraction or of a polynomial or whatever. And so you might already know a different way to calculate the derivative. And the reason why I mention this is that if you know two different ways to do the same question, yes, you have to use the limit definition, but you can check your answer by using the other method and making sure you get the same thing. I will talk about 14 in just a second. Are there any questions about this work first? Okay, so number 14. Number 14 is about this taxi company. And we have this function where the input is the number of cabs we deploy. And the output is the total fares collected. And the way this is modeled is with the function f of c equals 3600c over 1 plus the square root of c. So before we can really do anything, we have to first take the derivative here, because all the questions are about the derivative. So that's going to be a quotient rule question. So f prime of c here, it should be 3600 times 1 plus root c minus 3600c times 1 over 2 root c, all divided by 1 plus root c squared. Okay, so that's 3600 plus 3600 root c. Okay. And actually something pretty nice happens. So I have 3600 over 2, so that's 1800. And then I have a c over root c, so that is in fact root c. And so I'll end up getting 3600 plus 1800 root c divided by 1 plus root c squared. So when I then plug in the numbers, I get f prime of 4 is 800, and f prime of 25 is 350. Okay. And before we talk about what these mean, we have to pause for a moment and think about what the units here are supposed to be. And remember, the units of the derivative are always the units of the output over the units of the input. So this is dollars per cab, dollars per cab. Okay. So what do these things mean in this context? And so remember, the derivative is all about change. It's telling us how the output of our function, that is, how the total amount of fares we collected, changed as we changed the input. That is, as we, in this case, increased the number of cabs. And so when you see a statement like f prime of 4 equals 800, what this means really is that the last cab, that is the fourth cab, netted us an extra $800. So the fourth cab not every cab, just the fourth cab got us $800 extra. Okay. And the reason why I say it's the fourth is because it's really the last cab that got us that $800 extra. Okay. And you can compare that to f prime of 25, which is only $350. What this really means is that the 25th cab only got us $350. And this is actually pretty sensible because the more cabs you put out in the city, the more you saturate it with cabs, and then the less additional fares that you're able to get. But you can see, actually, even just in this small window going from 4 to 25, already the total fares, already the fares being collected by our last cab have gone down by more than half. And so our conclusion here is that we need to carefully control the number of cabs that we use, because if we let the number of cabs get out of hand, then the total amount of money we're going to be making off of them is going to end up being much less than the amount of money we're spending to run them. Okay, any questions about number 14? Any other questions that people want to talk about from this exam? Number 13, sure. Okay, so in this question, we have a graph that looks something like this. Marked off this point, -1, -2. And this is all on a graph of 2x over x plus 2. Okay, so first note, these two lines are perpendicular in the graph. So these lines are perpendicular. So we're going to need to use our fact about perpendicular lines having negative reciprocal slopes in order to solve this question. Okay. So this line, that is the tangent line. Its slope is going to be f prime of -1. Okay. So this other line, the line that I really want to look at, because it's the line that intersects the graph at the point I'm interested in, it's going to have slope -1 over f prime of -1. So this is going to end up being our key fact here. But before I can do anything with that, I need to actually calculate the derivative here so that I can figure out what f prime of -1 is. So this is a quotient rule question. Plus 4 minus 2x squared. Those cancel. So this is 4 over x plus 2 squared. Okay. So f prime of -1 is just 4. And so if I go ahead and highlight the line that we're interested in blue, then the blue line ends up having slope -1/4. So I want to actually find the equation of the blue line. It definitely looks like y equals -1/4 x plus b. Okay. It does contain the point -1, -2. So I'm going to plug that in, which will give me -2 equals -1/4 times -1 plus b. Okay. So that will give me that b is -9/4. Okay. In other words, the equation of the blue line is y equals -1/4 x minus 9/4. And the thing I'm looking for is where the blue line and the original graph intersect. So, in other words, I'm really trying to find where minus 1/4 x minus 9/4 equals 2x over x plus 2. Okay. That's the thing I want to know. That's the magic point where everything will work out. Okay. To solve this equation, it's quite helpful if I rewrite this side as being minus x plus 9 over 4. And so then when I cross multiply, that will give me minus 8x equals x plus 2 times x plus 9. And so if we simplify this a bit, I'll get 0 is x squared plus 19x plus 18, which actually factors pretty nicely. If I look back at the original graph, though, in light of this, I definitely am not asking for the x equals minus 1 intersection, because the x equals minus 1 intersection is that point. It's the one we started with. So I'm going to cross that out. I know that, by the way, because of this minus 1 here. That was sort of the solution I was expecting. Okay. Here's the other one. So that means if you look at this point, we now know that this point looks like minus 18 comma something. And we just have to figure out what the something is. And we figure out this something by plugging minus 18 into our function. So I'll do that up here. So f of minus 18, that's going to be equal to negative 36 divided by 16. Okay. And I can divide both of these things by 4. And so that will be minus 9/4. Okay. And that will work out as that. Okay, I will talk about 11.5 in a second. Are there any questions about A13 here? Okay, so let's talk about 11.5. So 11.5 asks you to identify where the critical points are in this graph, or identify a critical point in this graph. And just to skip right to the punchline, there aren't any. But let me go over why. Namely, remember there are basically 4 things a critical point can look like. It can look like that, it can look like that, it can look like that, or it can look like that. Remember, critical points are all about horizontal tangent lines. Okay. However, if you look at this, which I apologize, I have drawn all over my copy of this exam, but if you look at the graph, there are no spots in the graph where there is a horizontal tangent line. All the spots in this graph where I could plausibly draw a tangent line, all of those places, that tangent line has either positive slope or negative slope. There's nowhere it has zero slope. Now, I want to emphasize, this has nothing to do with the fact that this function has a bunch of holes and that kind of thing in it. I could definitely draw a graph that would look something like this. Where there would in fact be lots of, where there would in fact be lots of critical points. But the critical points would, in this case, if this were the graph, end up being here and here and here. Because again, those are the spots where the tangent line is horizontal. All right, any questions about that or any other questions? I should mention, by the way, I just got an email to this effect. YouTube saves this video automatically, so I'm going to do this tomorrow night with the other section. You're welcome to come live at 6 p.m. and do this and ask questions or whatever. But even if you have a commitment at 6 p.m., which maybe you do, it will still be posted to YouTube automatically, so you can watch tomorrow night's version of this, where I suspect most of the questions will be about sample final C, and then you could do that anyway. So even if you can't come tomorrow during to ask questions, you can still go back and review the video and skip through and see if any questions were going over that you wanted to talk about. And I have a request for 11.4. 11.4 is about horizontal and vertical asymptotes. And so it looks to me like there are two vertical asymptotes. One of them is here. A vertical asymptote, remember, is where the value of the function is spiking off to plus or minus infinity. So one of the vertical asymptotes is at x equals 2. The other is over down here. The value looks like it's spiking off to minus infinity, so that would be at x equals minus 2. And it does not appear from this graph like there are any horizontal asymptotes. Again, remember what a horizontal asymptote would look like is it would look something like this, where there's some horizontal value that the graph is approaching out at plus infinity or minus infinity. And so this would be a horizontal asymptote at y equals 0, but you might also have something like a horizontal asymptote like this, where maybe if this is y equals 2, then that would be the horizontal asymptote. Are there other questions people want to talk about? 11.2, sure. So 11.2 11.2 asks about the limit as x goes to minus 2 of this function. Okay, so I'm looking for inputs that live on this vertical line. And in particular, I'm looking for what happens at inputs that are close to this vertical line, but not on it. Okay. If I look on the left side, then it looks like the limit is going to this number, which is a little more than minus 1. However, if I look on the right side, it looks like the graph is actually going down to minus infinity. Okay. And so I can go ahead and write that down. The limit as x goes to minus 2 from the left of f of x, that looks like it's something like negative 0.9. The limit as x goes to minus 2 from the right of f of x, that looks like it's going to be minus infinity. Okay. But these two things are different. And so that means the original limit doesn't exist. So you can write does not exist or is undefined or DNE or whatever your favorite form of saying the limit is broken is. So just remember when you're asked about a limit, if there's no from the left or from the right on the limit, you really have to look at both, and both sides have to match. Any final questions for tonight? 12.5, sure. So 12.5 gives you this graph of the derivative and asks you to find the equation of the tangent line at x equals minus 4. And it tells you f of minus 4 is 2. Okay. Which is just flat out telling you that the point minus 4, 2 is on this tangent line. So the only thing I need is I need the slope. Okay, and remember that slope is going to be f prime of minus 4. Okay. And I can find f prime of minus 4 because I'm given a graph of the derivative. And so if you look here at this graph, that point right there tells me that f prime of minus 4 happens to be minus 4. Okay. Ascribe no significance to the fact that the minus 4 and the minus 4 match. That's just a coincidence. But now I know that my tangent line has an equation that looks like y equals minus 4x plus b. And I know that it passes through minus 4 too. So that is 2 is minus 4 times 4 plus b. So that tells me that b is 18. So the equation of the tangent line works out to be y equals minus 4x plus 18. Reminder, because I know a few people got confused about this on the similar question on the test, this is not the tangent line to this graph. The tangent line to this graph would definitely have positive slope, but this also is not the graph of f. This is the graph of f prime, and so that's the important thing to remember here. Okay, number 5 is a good one to go out on. Let's look at number 5. Okay, so number 5 gives us this function. Okay. And there are 2 points labeled on a graph of this function. And we are meant to identify what these 2 points are. Okay. And each of these points is special for a different reason. This one is special because it's an x-intercept. In particular, automatically, before I even do any work, it's on the x-axis, so its y-coordinate is 0. Okay. I'll have to do a tiny bit of work to figure out what the x-coordinate is that matches that. Okay. This point over down here is special because this is a critical point. So I have to remember how to go about finding my x-intercepts and how to go about finding my critical points. Okay, so to find the x-intercept, remember I'm looking for an input that gives me the output 0. That means I really want to figure out when f is equal to 0. Okay. But f is a fraction. And so we should know that we're looking at when the numerator is 0. Okay, which will give me 4x is minus 9, which will give me x is minus 9/4. Okay, so this is the input that gives me the output 0. And so that means that the coordinates of this point are minus 9/4 comma 0. I know that means the number minus 9/4 shows up twice on the test. I don't know why. Next, we want to look at the critical point. What's special about the critical point here is, remember, as always, this is a spot where the tangent line is horizontal. This is a place where the derivative is 0. So I want to figure out where the derivative is 0. Okay. Of course, I can't figure out where the derivative is 0 without finding the derivative. So let's find the derivative. Okay. This is a fraction, so I need to do that with the quotient rule. Okay. So f prime of x then is 4 times x squared plus 2x minus 4x plus 9 times 2x plus 2, all divided by x squared plus 2x squared. Okay. This is a mess, but I only care when it's 0. So again, I really only care about the numerator. So I'm going to just pull off the numerator here and start simplifying that. So that's going to be 4x squared plus 8x minus 8x squared minus 26x, sorry, plus 26x plus 18. Okay, so that will work out to be minus 4x squared plus, and that looks like 30, or sorry, no, that is minus 18x minus 18. I can definitely divide out a minus 2 there. And so when I do that, I will get 2x squared plus 9x plus 9 equals 0. And so I just need to factor this piece. So this will in fact factor as 2x plus 3 times x plus 3. Okay, so this is x is minus 3 halves, or x is minus 3. Okay. These are my two critical numbers. Okay. I have to look back at the graph, though, and decide which one this is. And if you look closely, there's actually another critical number over here. And so this is the critical number that's bigger. It's the one that's closer to 0. Or alternatively, if you like, this point is clearly bigger than that one. So this number's bigger than minus 9/4. And the only one of these two that's bigger than minus 9/4 is minus 3 halves. Okay. So whichever way you slice it, this is the one we're actually looking for. And so our point looks like minus 3 halves, comma. And then I've got to calculate f of minus 3 halves. And I'll leave that part to you. But that is what's going to go there. All right, let's wrap up there for tonight. Again, you're welcome to come tomorrow night and ask more questions. You're welcome to come to office hours tomorrow morning and ask more questions. So if you've got more, by all means bring them, and you've got plenty of time to meet with me and talk about them. Also, don't forget there's Math Clinic, so you can go there and talk to them about it too if you want to talk to someone right now. But for tonight, let's wrap up there. I hope this was helpful and effective at getting you the questions you need answered. Really, this week is just all aimed at polishing up any little things that you didn't quite get over the course of this very, very fast-paced course. So it's very likely there are lots of little details sort of missing or that you've forgotten about. So this is just an opportunity for you to do a bunch of problems of all the types that will show up on the final, just to make sure you feel prepared and you go in knowing that you know what you need to know. But let's wrap up there for tonight. Have a wonderful evening. Stay safe, stay healthy, and I will see you on Wednesday or tomorrow or in office hours, whichever happens. Bye for now.